Okay, good day. Today we're going to go back in time a little bit and we're going to do a lesson on counting. Now, I know that you're probably wondering why this is AP chemistry? Why am I learning about counting? And that's something that should have been taught in elementary school or earlier. Well, turns out that in chemistry, we have to count things like atoms. And in order to do that, we need to learn some new terms. So, uh, when we use counting in the real world, one of the things that typically pops to mind for this kind of idea is like if I go to the store and you buy eggs, you typically buy or donuts. Donuts are not as healthy, but if you buy eggs, eggs come in dozens. Okay, so if I buy a dozen eggs, everybody knows that dozen means you have 12 eggs. You don't usually buy individual eggs. I say I want one dozen eggs, and that means you get 12 eggs with that. Same thing if you go to the office supply store and you want to buy paper. So if you got buy paper usually don't buy a sheet at a time. You buy a pack of paper, a ream of paper that's called. So ream is another counting term. A ream of paper, right here, where is it? Says 500 sheets. So if I buy one ream of paper, I know I'm getting 500 sheets of paper in this packet. Right now, it does not have 500 sheets. I'm down to this. And so counting, those are countable numbers. If I count 12 eggs or I count 500 sheets of paper, you can count those individually. But if I go to the chemical lab and I say I need you to get me some chemical like calcium nitrate or sodium chloride or something like that, and I want you to or some number of if I want certain numbers of molecules or atoms, I can't count out a dozen atoms or a ream of atoms. That's like, so I have here some salt. This is table salt. Table salt is the formula sodium chloride, and it's in a little crystal structure. And this little tiny crystal here, I don't know if you can see that, a tiny crystal of salt actually has billions and billions of atoms in it, and salt crystals and formula units of salt. So there's billions of things in there. You cannot count that. And so what scientists had to come up with was a different unit for counting things in chemistry, and that is the mole. And so the mole is this really, really big number. It's 6.022 times 10 to the 23rd power. It's got a 6 and basically 23 zeros after it. And so it's this giant number. If you have that many atoms of something, that's called a mole of something. And so what I'm going to do in just a second is I'm going to show you some examples of how what can we do with this giant number. What does it even mean? What does it look like in real life? If I want to get a mole of table salt particles, what would that actually look like? So I'm going to show that to you in just a second. So as I said earlier, this mole, it's a giant number. It's this huge number, and I showed you 6.022 times 10 to the 23rd. If I had one mole of something, it's that many. It's like this giant number here. I'll post a video also that you can look at. It's a short TED Talk that talks about how big the mole is and what the history of the mole and all that stuff. And it's really kind of cool. But one example that they give is if you had donuts, if you had a mole of donuts and you covered the earth, it would cover the earth so many times that it'd be 5 miles deep in donuts. So that's how big this number is. But if I were to look at atoms, because atoms are really small, I can actually have a mole of something on my tabletop. So this is aluminum. Aluminum is an element, and if I had aluminum cans and I had some foil and I put it onto a scale, that's about what 1 mole of aluminum looks like. So it's 2 cans. It's 1 big can, 1 small can, and then some aluminum foil stacked on top of that. And you wonder, well, how do I get this number? So if I actually look at aluminum on the periodic table, it's right here. So this is the periodic table. And on the bottom here, we learned that this is the mass. And what this number also tells me is something called the molar mass. So molar mass says, well, if I have 1 mole of aluminum, 1 mole of aluminum is actually 26.98 grams. And so this right here, this is about 26.98 grams, a little less than that. But that's what 1 mole of aluminum atoms looks like in real life. And so if I'm going to write out something called a molar mass equality, so that the next assignment you're going to be asked to do is to write out molar mass equalities, we write out 1 mole of aluminum. So mole, you can actually abbreviate mole, MOL. I know it's not much of an abbreviation, but it is 25% of the word. So you cut out 1 letter, and then you write out equals 26.98 grams of aluminum. And the reason why we keep all these things here is because when we start getting into this thing called stoichiometry, it's important that we kind of keep track of what am I writing grams and moles for, because it's going to start getting lots of units everywhere. So 1 mole of aluminum is 26.98 grams. If I were to look at another element, so copper, I know that pennies are not pure copper anymore, but if pennies were actually pure copper, this is what a mole of copper kind of looks like. It's not that much. It's a couple pennies. And if I look at the periodic table, copper is right here in the periodic table. And that is 63.55 grams. And so if I have 1 mole of copper, if I'm going to write a molar mass equality for copper, 1 mole of Cu equals 63.55 grams of Cu. That's about that much. Same thing with zinc. I have some zinc nails here. Nails are primarily zinc. We'll just say they're pure zinc. Same thing, 65.38. I couldn't quite get, the nails weren't quite, I couldn't break off a nail. But about that, so that's about what a mole of zinc looks like. So if I write 1 mole of zinc is 65.38 grams. Well, what if we have something like table salt now? So table salt is a compound. And compounds are not pure elements. They're 2 different things stuck together. But if I have a mole of table salt, that's about what a mole of table salt looks like. It's 58.4 grams. And if I look at the periodic table, well, I can see that Na is 22.99, but Cl is 35.45. What do I do with these numbers? Well, there's 1 Na and there's 1 Cl. If I just add them up, I actually get 58.44 grams. So compounds you treat the same way as you do an element, except if I have compounds with 2 different things, now I have to add up the substances. And 1 Na and 1 Cl are going to add those 2 things up and get the molar mass of sodium chloride. Now, what happens when we have a compound that has a number after it? So this is hydrogen, so H2O, water, and water has 2 subscript. It's called a subscript. And when you have a subscript in a formula, that tells you that you have 2 or whatever number of that particular substance that it's after. So hydrogen's here. The 2 comes after the hydrogen. Therefore, it means that I have 2 hydrogens. If there's no number after something, that implies that there's only 1 of that substance, so there's only 1 oxygen. So here, I have 2 hydrogens. I'm going to take the 1.08, multiply it by 2, and then I'm going to add it to the oxygen, which is 16. And so you end up with about 18.01. Or O2. So you add that up, If you round it to the hundredths place, 18.02 grams. Once again, molar mass, write it out. 1 mole of H2O is 18.02 grams of water, H2O. And so that's how you do a basic compound. Now, if I have a compound that's something like calcium nitrate, so I mentioned calcium nitrate earlier, and if I look at this formula here, it's got parentheses in it. So I have this calcium, and NO3 is the nitrate group, and I have a 2 after the NO3. Well, what does that 2 mean here? So inside here, I have 1 nitrogen, so there's 1 of these, but then there's 3 of the oxygens because the 3 comes after the O. So there's 3 of these. Okay, so if I have an N, and I actually have, I'm going to draw this out. So I have 3 O's. This is a group like this. And I have calcium here. So there's only 1 calcium. There's nothing after it. Well, this 2 here tells me that there's actually 2 of the nitrate groups. So in this formula, I've got 1 calcium, a nitrate group, and I actually have another nitrate group like this. I have an N and 3 O's. And so what does that tell me in terms of calculating stuff for this formula? Well, I need 1 of these. Nitrogen, I have 2 of them. So if you drew it out, or you can just take the 2 kind of distributes itself amongst whatever is inside here. So I have 2 of the ends, and I have O3 times 2, so 6 O's. Not 5. Common error is people adding these up, but you don't want to add them. You want to multiply them. So I have 6 O's. And then when you do the math here, so you take all that, 1 calcium, 2 nitrogens, and 6 oxygens. You add all that up. You multiply those out. You get these numbers. Take all that, add it together, and you end up with 164.10. That is the molar mass of calcium nitrate, and then it's in grams. Okay, so try that out, do some of the problems, and then we'll start thinking about how do I use this what do I do with grams and moles, all this stuff. How do I use those units? Well, we're writing out the units so that we can do those calculations a little bit later.